This is very simple as the classical square cut of Azharuddin. Just know where the fielders are, just know the strength. Yes, the ball is placed in the gap. Beautiful. Why this minus again? Why object distance has become minus? Because it is a concave mirror. Stopping potential of photoelectrons of the nth bright fringe from the center, nth dark fringe from the center. Continuing with the next question. An object is placed at 20 centimeter distance in front of concave mirror. Please to highlight, students, it is concave mirror. So the object is placed at a distance of 20 centimeter in front of concave mirror, produces 3 times magnified. 3 times magnified real image. Very important. Magnification is 3 times and the nature of the image is real image. What is focal length of concave mirror? Recall the expression for magnification in terms of focal length. Very good. M equals F divided by F minus U. Magnification in terms of focal length. M equals F divided by F minus U. How much is M? Magnification is 3 times. Mistake minus 3 bardro. Since real image is formed, magnification is negative. Nenpitkoli. Wherever real images are formed, magnification is negative. This is equal to focal length has to be calculated F minus. Now object distance is 20 centimeter. Should I convert it into meters? No need. All my 4 options are in terms of centimeters. Centimeter kulli. So minus 20. Why this minus again? Why object distance has become minus? Because it is a concave mirror. So minus 3 equals F divided by F plus 20. Now on simplification, here F turns out to be minus 15 centimeter. But since it is a concave mirror, focal length cannot be negative. So F has to be positive. So F is 15 centimeter. So the answer is 15 centimeter. Next one. Very direct, very simple question. Focal length of a lens is 10 centimeter. Power of a lens in diopter. SI unit for power is diopter. So my dear students, how is focal length related to power? They are inversely related. So power is equal to 1 by F. This relation na 1 mark ge board exam alli bahalastu sadi kelidare. How is Power of a lens related to its focal length. Power is always equal to 1 by F, or F equals 1 by P. So P equals 1 by. Now I have to keep power in diopter, SI unit. So 10 centimeter has to be converted to meter, 0.1. So 1 by 0.1, 10 diopter will be the answer. Students, this is one concept which is taken out from your syllabus, so I will not concentrate on that. 24th. The fringe width of the fringes beta ant kariತೀವಿ is 0.002 centimeter. Fringe width ಕೊಟ್ಟಿದ್ದಾರೆ. Beta is given. What is the distance of the fifth dark fringe from the center? ಏನ್ ಕೇಳಿದ್ದಾರೆ? Distance of fifth dark fringe from the center, which means ಈಗ dark fringe formula recall ಮಾಡೋಣ. 2n plus 1 lambda d divided by 2d. Interference ಆ ಪಾಠದಲ್ಲಿ ಬರುತ್ತಲ್ಲ, ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ ದಿ nth ಬ್ರೈಟ್ ಫ್ರಿಂಜ್ ಫ್ರಮ್ ದಿ ಸೆಂಟರ್, nth ಡಾರ್ಕ್ ಫ್ರಿಂಜ್ ಫ್ರಮ್ ದಿ ಸೆಂಟರ್. ಕ್ವೆಶ್ಚನ್ ಅಲ್ಲಿ ಡಾರ್ಕ್ ಫ್ರಿಂಜ್ ಕೊಟ್ಟಿರೋದ್ರಿಂದ ಇಟ್ ಇಸ್ 2n plus 1 lambda d divided by 2d. Now, if you observe, what is this lambda d by small d? ಅದೇ ಅಲ್ವಾ ಬೀಟಾ, ಡೆರಿವೇಶನ್ ಮಾಡಿದ್ವಲ್ವಾ ಫ್ರಿಂಜ್ ವಿಡ್ತ್ ಗೆ ಬೀಟಾ. ದಿಸ್ lambda d by d itself is beta. So this expression reduces to 2n plus 1 beta by 2. Beta ಎಲ್ಲಿಂದ ಬಂತು? It is lambda d by d. And what is n now? 4. ಅಲ್ಲಿ ಫಿಫ್ತ್ ಡಾರ್ಕ್ ಫ್ರಿಂಜ್ ಅಂತಿದೆ. ಡಾರ್ಕ್ ಫ್ರಿಂಜ್ ಆಗಿರೋದ್ರಿಂದ ಆಲ್ವೇಸ್ ರಿಮೆಂಬರ್ n is 1 less than the given fringe. ಬ್ರೈಟ್ ಫ್ರಿಂಜ್ ಆದ್ರೆ ಎಷ್ಟು ಕೊಟ್ಟಿರ್ತಾರೆ ಅಷ್ಟೇ ಬರ್ಕೊಳ್ಳಿ. ಸೆಕೆಂಡ್ ಬ್ರೈಟ್ ಫ್ರಿಂಜ್ ಅಂದ್ರೆ n is 2, ಫೋರ್ತ್ ಬ್ರೈಟ್ ಫ್ರಿಂಜ್ ಅಂದ್ರೆ n is 4. ಡಾರ್ಕ್ ಫ್ರಿಂಜ್ ಅಂದ್ರೆ it is 1 less than the given one. So this is 2 into 4 plus 1 beta 2 into 10 power minus 3 ಬರೀತೀನಿ divided by 2. ಎಲ್ಲ ಆಪ್ಷನ್ ಸೆಂಟಿಮೀಟರ್ ಅಲ್ಲಿ ಇದೆ. That is why I have kept it in centimeter only. So this is 8 plus 1 9 millimeter. Please to observe here, all the 4 options are wrong. I've given you the correct answer. This goes for a grace mark. So 9 millimeter is the answer. Now, diameter of the objective of a telescope is 200 centimeter. Diameter ಕೊಟ್ಟಿದ್ದಾರೆ. What is the resolving power of the telescope if the wavelength is 5000 angstrom? ಮಕ್ಕಳ, ಇದು ಟೆಲಿಸ್ಕೋಪ್, ಮೈಕ್ರೋಸ್ಕೋಪ್ ಅಲ್ಲ. ಸೊ ಟೆಲಿಸ್ಕೋಪ್ಗೆ ರಿಸಾಲ್ವಿಂಗ್ ಪವರ್ ಏನಾಗಿರುತ್ತೆ? d divided by 1.22 lambda, where d is the diameter of the objective, lambda is the wavelength of the light used. Diameter 200 centimeter ಇದೆ. So which is, if you convert it into meters, so 200 into 10 power minus 2. So this is 1.22. Wavelength is 5000 angstroms into 10 power minus 10. So if you simplify, fourth option will be the answer. Now, a polarized light, polarization chapter, Brewster's law, Moll's law ella baruttalva. Polarized light of intensity I0 is passed through another polarizer whose axis makes an angle of 60 degrees with the former. What is the intensity of the emergent polarized light from the second polarizer? Intensity, polarizer, pass axis ಬಂದ ತಕ್ಷಣ it is Moll's law. Hint ಇದು. Polarized light, polarizers, intensity, pass axis, ಇದು ಬಂದ ತಕ್ಷಣ it becomes, yes, Moll's law. Moll's law ಇಂದ ಏನು ಕಲ್ತ್ಕೊಂಡ್ವಿ? I equals I0 cos square theta. So please to know, this is what you call as Moll's law. So this is I0 cos square 60 degrees. So this is I0 by 4. So the answer is I0 by 4. Next, what is the de Broglie wavelength of the electron accelerated through a potential difference of 100 volts? ಏನು ಕೇಳಿದ್ದಾರೆ ಪ್ರಶ್ನೆ ಗಮನಿಸಿ. De Broglie wavelength in terms of potential, kinetic energy alla, mass alla. It is in terms of potential. Nenpaitu sir. So in terms of potential, please know this. De Broglie wavelength lambda is 12.27 divided by root V. Potential express ಮಾಡಬೇಕಾದ್ರೆ de Broglie wavelength is 12.27 divided by root V. So this is 12.27 root of V ಎಷ್ಟು 100. Potential ಕೊಟ್ಟಿದ್ದಾರೆ 100 volts, or this is 12.27 divided by 10, somewhere 1.22 angstroms should be the answer. Maximum kinetic energy of the photoelectrons depends on 101 times I have discussed kinetic energy, stopping potential of photoelectrons. They always depends upon frequency. Photoelectric current depends upon intensity. So kinetic energy, stopping potential depends upon frequency. Which of the following spectral series of hydrogen atom is lying in the visible range? Hydrogen spectrum do yava series visible range al present agide? Passion series near infrared region al ಕಾಣಿಸ್ಕೊಳ್ಳುತ್ತೆ. Fun series far infrared region al ಕಾಣಿಸ್ಕೊಳ್ಳುತ್ತೆ. Lyman series UV regional ಕಾಣಿಸ್ಕೊಳ್ಳುತ್ತೆ. Balmer series it is present in the visible region. So which series lies in the visible region? It is the Balmer series. What is the energy of the electron revolving in the third orbit expressed in electron volts? So third orbit energy of the electron, if you know your hydrogen spectrum, it is 1.51 electron volt. Next. The relation between half-life and decay constant lambda has to be calculated. Half-life ardhamsha and decay constant lambda. To do this, I will consider my radioactive decay law. ಏನು ಬರೆದ್ವಿ expression? Radioactive decay law in the N equals N naught e to the power minus lambda T. Remaining number of atoms, initial number of atoms. Half-life anno concept, ardhamsha. That means N is N naught by 2. This is N naught e power minus lambda. This happens when time period is capital T, which is half-life. This N naught cancels. Half is e power minus lambda T, or 2 equals e power lambda T. If I need to eliminate this exponential, I need a logarithm on the other side. Therefore, this becomes log E2 equals lambda T. ಈ ಎಕ್ಸ್ಪೋನೆನ್ಷಿಯಲ್ ತೆಗಿಬೇಕಾದ್ರೆ ಇಲ್ಲಿ log e ಹಾಕೋಬೇಕು. So log e2 is lambda t. So the third option is the correct answer. Force between two protons is the same as the force between proton and neutron. Force between two protons and the force between a proton and a neutron are same. The nature of the force is, yes, which force in nature is charge independent? Strong nuclear force. It doesn't depend upon the charge of the interacting particles. Independent of the charge, so strong nuclear force. In an n-type semiconductor, electrons are majority charge carriers, yes, but it doesn't show any negative charge. Although electrons being majority charge carriers responsible for conduction in n-type semiconductor, that negative character is not shown. Why? That is because atom is electrically neutral. For the given digital circuit, again, umpteen number of times, so almost all my previous sessions, I worked this out. It is AND gate. Again, this is not in your present syllabus. Since you're not exposed to alpha, beta definitions, I don't concentrate on this. A tuned amplifier circuit, one amplifier circuit is used to generate a carrier of frequency 2 megahertz. Then the value of root LC, frequency as related to root LC. We know F is 1 by 2 pi root LC. That is 1 by, so root LC bekiga. 2 pi into f. Nodi, if you see the options, I need not simplify also. Ee one formal tandre try to. So this is 1 by 2 pi into f esto 2 megahertz under 10 power 6. So 1 by 4 pi. Nodi? This is very simple as the classical square cut of Azuruddin. Just know where the fielders are. Just know this trend. Yes, the ball is placed in the gap. Beautiful. If a charge on the body, so Q kottidare, charge on the body is 1 nanocoulomb, how many electrons are present on the body? So simple. I know from the quantization rule, Q is N into E. How many? Andre N kandidibekaste Q divided by E. Q is 1 nanocoulomb. Nano 1.6 into 10 power minus 19 charge of the electron. So if you simplify, the answer is 6.25 into 10 power 9. This is again a problem which I worked out in the previous session. 2 will be the answer. What is the nature of Gaussian surface? Any Gaussian surface, adana area vector ant karve nenpidya? All the 3 applications of Gauss law: straight wire, plane sheet, spherical shell. We call something as area vector. So Gaussian surface is always a vector. What is the electric potential at a distance of 9 centimeter from 3 nanocoulomb charge? Such easy questions. Just know basic relations. Potential V is 1 by 4 pi epsilon naught Q by R. What is the value of 1 by 4 pi epsilon naught? 9 into 10 power 9. Q is to 3 nano matpuna. R 9 centimeter. 9 into 10 power minus 2 plus 9 minus 9 hoito 3 into 10 power 2. So 300 volt is the answer. See how simple. Do you require any magic to do this? Any classical physics to do this? No. Simple concepts.